Welcome back to Mr. Vaughn's classroom, where math is made easy. In this lesson, we're going to look at Unit 7 on quadratic equations, Lesson 8. This is the third part of rewriting quadratic expressions in factored form. Before we get started, I'd like to ask you to give this video a thumbs up, hit the subscribe button, and engage with a comment below. Our learning goal today is to look closely at some special kinds of factors. We have two learning targets today. At the end of the lesson, we'll come back and we'll review these to make sure you've learned everything you needed to from this lesson. Learning target number 1 says that you can explain why multiplying a sum and a difference, such as x plus a number times x minus a number, results in a quadratic expression with no linear term. What we're going to see is that you end up with a positive mx minus mx, so they're going to cancel each other out, therefore resulting in a quadratic expression that only has the ax squared term and the c term. Learning target number 2 says that when given quadratic expressions in standard form, x squared plus bx plus c, you'll be able to rewrite them in factored form. The first glossary term we have for this lesson is coefficient. The coefficient is the number that we multiply a variable by. So in the examples that they give here, when we see 3x plus 2, the coefficient is the 3 that is multiplying x. Then when we see 5 plus p, here we would say that the coefficient is understood to be 1. Because multiplying by 1 doesn't change anything, we don't actually need to show the 1. Our next glossary term is constant term. This is when you have a number all by itself without a variable. So in the examples they're giving here, we have 5x minus 8. So the constant term is negative 8. It is the number that does not have the variable with it. And an important thing is that you want to make sure you keep the sign with it. So if you see 5x minus 8, you can think of that as being 5x plus negative 8. So make sure that if it's minus 8, you keep that negative sign with the number. They give us another example here, 12x minus 4. Make sure you keep that minus with the 4, so you say that the constant term is negative 4. Our next glossary term is linear term. This is going to be the bx term in standard form. When you have x to the first power, this is when we say you have a linear term. So in standard form, bx is your linear term. If we're looking at factored form, then we would say we have two linear terms being multiplied together, because we're going to have one factor that has an x to the first power, and we're going to have another factor that has an x to the first power. So both of those factors are linear terms. And our last glossary term for this lesson is zero product property. This is when we say that if you're multiplying numbers together and you're getting 0 as an answer, then one of those items that you are multiplying must be 0, because there's no possible way to multiply and get an answer of 0 without multiplying by 0. And we're going to use this a ton throughout the entire unit, because this is how we find our factors, by setting them equal to 0 and using them to find the x-intercepts. Our first practice problem for lesson 8 wants us to match the quadratic expression given in factored form on the left with an equivalent expression in standard form on the right. And in order to not allow us to use process of elimination, they've given us one more correct answer on the right, so one of these will not get used. So in order to better diagram the distributive property here, I'm going to do it step by step with all 4 problems at the same time, and then change colors to ensure you see where these numbers are coming from. So the first thing I'm going to do is I'm going to multiply the first number in the left factor with the first number in the right factor. So I have y times y, which results in y squared. On choice B, I have 11 times 11, which results in 121. In choice C, I have x times x, which gives us x squared. And on D, I've got x times x, which we said gives us x squared. Now I'm going to change colors, and I'm going to take the first term in the left factor, and I'm going to multiply it by the last term in the right factor. So y times negative x, don't forget the negative sign here, that's going to give us negative xy. On B, I'm going to have 11 times negative x, so that's negative 11x. On C, we're going to have x times positive 11, so that's plus 11x. And on D, we're going to have x times negative y, so that's negative xy. Change colors again. Now I'm going to take the second term in the first factor, and I'm going to multiply it by the first term in the second factor. So x times y is plus xy. Then we have x times 11, so that's plus 11x. Then we have negative 11 times x, so that's minus 11x. And then we have negative y times x, so that's minus xy. And one more color change. We're going to take the second term in the first factor, and we're going to multiply it by the second term in the second factor. So we have x times negative x, that's negative x squared. Then we have x times negative x again, so that's negative x squared. Then we have negative 11 times positive 11. So that's negative 121. And we have negative y times negative y. So that's plus y squared, because a negative times a negative is a positive. So now let's look at the problems that we have. I have y squared minus xy plus xy minus x squared. Well, I can combine like terms. So I have a minus xy plus xy. Those are going to cancel each other out because they go to 0. So now I have y squared minus x squared, and I see that on number 3. So A matches number 3. On B, we have 121 minus 11x plus 11x minus x squared. I can combine like terms, and a minus 11x plus 11x cancel each other out because they add to 0. So now I have 121 minus x squared, and I see that in number 1. So B matches number 1. When I look at C, I have x squared plus 11x minus 11x minus 121. I can combine like terms, so 11x minus 11x is 0. They cancel each other out. That leaves me with x squared minus 121, and we see that down here in number 5. That means C matches number 5. And our last one, D, we have x squared minus xy minus xy plus y squared. I can combine like terms, so this is going to become x squared. If I have minus xy minus xy, that becomes minus 2xy. And then I bring down the plus y squared. And we see that right here in number 4. So what you can see here is that when you are multiplying the same factor but with a different sign, you actually end up eliminating that bx term. We saw that in choice A, B, and C. Down in D, when we multiplied the exact same factor, we ended up with ax squared minus 2bx plus c squared. If you have any questions about any part of this practice problem, please leave a comment below, and I'll get back to you with any help that I can offer. Practice problem number 2 says both x minus 3 times x plus 3 and 3 minus x times 3 plus x contain a sum and a difference and have only 3 and x in each factor. If each expression is written in standard form, will the two expressions be the same? Explain or show your reasoning. So, on the surface, they're trying to show you some similarities and lead you to believe that these are actually the same thing. But you need to pay very careful attention to what they're actually showing you. In the first, we have two positive x's. And we have opposite 3's. We have a negative 3 and a positive 3. In the second, we have two positive 3's. And we have opposite x terms. We have a negative x and a positive x. Therefore, no, these are not the same. But let's go ahead and prove it. And I'm going to use the same color coding method that I used previously. So in the first one, I'm going to have x times x, which gives me x squared. And in the second one, I'm going to have 3 times 3, which gives me 9. Next, I'm going to have x times 3, which gives me plus 3x. And I'm going to have 3 times x, which also gives me plus 3x. Next, we have negative 3 times x, which gives me minus 3x. And I have negative x times 3, which gives me minus 3x. And finally, I have negative 3 times positive 3, which gives me minus 9. And I have minus x times positive x, which gives me minus x squared. So in the first one, in the middle, I have plus 3x and minus 3x. Those cancel each other out. And in the second one, the same thing happens. Plus 3x minus 3x cancel each other out. And what we're left with are x squared minus 9 and 9 minus x squared. So as you can see, in the first one, I have a positive x squared and a negative 9. But in the second one, I have the opposite. I now have a positive 9 and a negative x squared. So, as we said, these are not the same thing. If you have any questions about any part of this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 3 might seem a little daunting and quite confusing. So let's slowly break down what each part is telling us and what each part is asking us to do. Number 1 is pretty straightforward. They want us to show that the factored expression 5 plus 1 times 5 minus 1 and 5 squared minus 1 squared are equivalent. So here we've done this a bunch. We're simply going to use the distributive property. If I've got 5 plus 1 times 5 minus 1, then I have 5 times 5, which equals 25. I've got 5 times negative 1, which is negative 5. Then I've got 1 times 5, which is positive 5. And I've got 1 times negative 1, which is negative 1. Now, the negative 5 and the positive 5 are going to cancel each other out. So that leaves me with 25 minus 1. I could take this and I could rewrite 25 as being 5 squared. And I could take this 1 and I could rewrite it as 1 squared. And then I just bring down the minus sign. So now we've taken this factored form they've given us and we've turned it into what they asked us to show it was equivalent to. So that's all we need to do for number 1. Now number 2 is giving us the same thing, only this time instead of 5 and 1, we're using 30 and 2. They're telling us that 30 minus 2 times 30 plus 2 and 30 squared minus 2 squared are equivalent. And we saw why in number 1. This time they're telling us that these can help us find the product of two numbers, and they want to know which two numbers they are. So the easiest way to do this is take that factored form, 30 minus 2 times 30 plus 2, because the word product means the answer you get when you multiply. And here I have a multiplication problem. So 30 minus 2 is 28. And 30 plus 2 is 32. So these are the two numbers that we are multiplying. 28 and 32. If I multiply these together, the answer will be the same as if I used this factored form, and if I were to use this subtraction problem with the squares. Now we move down to number 3, and they're going in reverse order this time. Now they're telling us the two numbers, 94 and 106. They want us to write 94 times 106 as a product of a sum and a difference. So what they are really wanting you to do is what we just did in number 2, but in reverse order. They want us to start with 94 times 106 and turn them in to a factor that is addition and a factor that is subtraction. And this is where it helps to notice patterns. Because if you start to notice patterns, notice we were adding 1 to 5 and we were subtracting 1 from 5. We were subtracting 2 from 30 and we were adding 2 from 30. So we're trying to add and subtract the same number. Well, 106 and 94 are 12 apart. Half of that is 6. So if you think about what is 6 away from 94, it's 100. And what is 6 away from 106? It's also 100. So we can rewrite this as 100 minus 6 gives us 94, and 100 plus 6 gives us 106. So we took number 2 and we did it in reverse order. So that's the first part of number 3. It says, then write it as a difference of 2 squares. So if you look back up at the top, once we had it in factored form, such as 5 plus 1 and 5 minus 1, or 30 minus 2 and 30 plus 2, then we simply wrote it as the first number, such as 5 squared or 30 squared, minus the second number squared, 1 squared or 2 squared. So now we're going to take the 100 and we're going to square it. Then we're going to put a minus sign, and the other number that was repeated was 6. So we're going to square those. And the last part is asking, what is the value of 94 times 106? Well, if I was to ask you that problem, you would probably go to a calculator to put that in. But now that we've done these steps, you can probably do this in your head. We have 100 squared. So 100 times 100 is going to be 4 zeros and a 1. So it's 10,000. Then 6 squared is 36. And 10,000 minus 36 is going to be 9,964. So now, a problem that I would have had to use my calculator for I can do in my head. And just to prove that we're right, let's double check it in a calculator. "94 times 106 is 9,964. Exactly what we were able to do in our head once we chose this different method. If you have any questions about any part of this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. This is our last practice problem for Lesson 8. They want us to write each expression in factored form, and they want us to write not possible if we can't change it to factored form. So I want you to first take a minute and look at each of these expressions and see if you notice a pattern. What I'm hoping that you notice is that all of these are ax squared and c squared. There is no bx term. Okay? So, if you think back to everything we've done in this lesson, in order to get rid of the bx term, you must be multiplying opposite factors. So, for example, on number 1, we have x squared minus 144. So I'm going to think to myself, I know I need opposite factors. So one of these needs to be plus and one of these needs to be minus. Now, how would I create x squared? Well, I would multiply x times x. How would I create 144? I would multiply 12 times 12. So now, because they are opposites, I would get x times x is x squared. Then I would have 12x and minus 12x. So the bx terms cancel out. And then I have 12 times negative 12 is negative 144. So this is how I would change from the standard form to the factored form. But here's something you need to notice about number 2. Number 2 has a plus sign. If you multiply opposite factors, it's impossible to get a plus sign. Remember, in order to make a positive, you need to multiply a positive times a positive or a negative times a negative. So your factors would need to have the same sign. If you know that your signs have to be opposites, then a positive times a negative will always result in a negative. So, understanding that, when I look at number 2, I have x squared plus 16. It is not possible to factor this. Because if I tried x plus 4 times x minus 4, I would end up with minus 16. So now let's look at number 3. We've got 25 minus x squared. So if I think about how to factor this, the first and most important part is that we have the minus sign. This lets me know that I can factor it. So to get 25, that is 5 times 5. And to get x squared, that is x times x. Now you make one of them positive and one of them negative, and you have your factored form. Looking at number 4, we have b squared minus a squared. So this one works because we have the minus sign. We know that in order to make b squared, we need to have b times b. We know that in order to get the minus sign, we need one of these to be positive and one of these to be negative. And then in order to get a squared, it needs to be a times a. And now our last one, number 5, we have 100 plus y squared. Well, notice we have the plus sign again, just like we did in number 2. And for the same reason, if you multiply opposite factors, there's no possible way to get a plus sign, because a positive times a negative is a negative. And we know that in order for there not to be a bx term here, then we have to be multiplying these opposite factors. So this one again would be not possible. So what you really need to remember from this practice problem is that when you see that you have an ax squared term and you have this c squared term, or even just any c term, but you notice that your bx term is missing, you need to understand that in order for that bx term to get canceled out, you need to be multiplying opposite factors. That way you have a plus bx and a minus bx. They add to 0 and cancel each other out. So you know that when you factor it, you're going to be multiplying the same factor but with opposite signs. Now, before we finish this lesson completely, let's go back, take a look at our learning targets, and make sure you've learned everything you needed to from this lesson. So in this lesson, we had 2 learning targets. Number 1 said that you can explain why multiplying a sum and a difference, such as x plus m times x minus m, results in a quadratic expression with no linear term. And we said that's because when you do the distribution property, you're going to end up having negative mx plus mx, which cancels out to 0. So that results in the linear term being eliminated. So when you see that your standard form does not have that bx linear term, you know that you're multiplying factors where one of them is a sum and one of them is a difference. And learning target number 2 says that when given quadratic expressions in standard form, ax squared plus bx plus c, that you are able to write them in factored form. And this was our 3rd lesson looking at how to do that in different situations. In this lesson, we were focusing on how you do it when you notice that they don't have a linear term or a bx term. So if you see that you have ax squared and you have c, and you notice that you have a minus c, then you know that you've got a sum for one of your factors and a difference for the other factor. If you notice that you have ax squared plus c, you should understand now that that is not possible, because if I multiply a sum and a difference, I'm going to get a minus c, not a plus c. If you have any questions about anything we covered in this lesson, please remember to leave a comment below, and I'll get back to you with any help that I can offer. In the bottom left of the screen, you should see a video that YouTube believes will be helpful to you. I ask you to please give this video a thumbs up, hit the subscribe button, and I look forward to seeing you in the next lesson.